This video will show images of Mars taken by the Hubble Telescope over a number of years, from 1990 to 2016. So the Hubble Telescope went into service in 1990, and it had a problem with focus. It was out of focus and did not take a great image of Mars. But here's December 13th, 1990. This is near the time of opposition. I'll explain that in just a second. But Mars, such and such a distance, 53 million miles from the Earth. So it kind of gives us an overview of big structures on the surface of Mars, but not the best. The Hubble Telescope was serviced by astronauts, and they replaced instruments in the telescope and put in a little extra optical aid, kind of like glasses, and brought the telescope such that it could be used and take better pictures. So we'll get to those. But let's go ahead and advance to the next one. So talking about opposition means that the planet is 180 degrees away from the sun in the sky. And for Mars, this occurs about every 2 years and 2 months. So in 2003, here's Mars, and here's the Earth, and here's the sun. So Mars opposite in the sky from the direction to the sun. Earth and Mars both have elliptical orbits, not circular. Mars much more elliptical than the Earth's orbit. But our best condition, shown here in 2003, is when the Earth is far away from the sun, and Mars is at a point in its orbit that's closer to the sun. And the less favorable conditions, so here's one that's 60 million miles, and here the Earth is a little closer than average to the sun in its orbit, and Mars is further out in its orbit from the sun. It's not leaving its orbit. The orbits are elliptical. In those elliptical paths, there's a place called perihelion, where the planet is closer to the sun, and then there's aphelion when it's far away. So in a situation like this, here's perihelion for the Earth, aphelion for Mars, generates a big distance. But aphelion for the Earth, far from the sun, and perihelion for Mars, closer to the sun, then we get our best observing conditions. And 2003 was an exceptionally good opposition, meaning Mars is close and easier to see details. So angular size changes depending on the distance of Mars from the Earth, and opposition gives us the best view when that's sort of every 2 years. That's sort of our best opportunity for having the closest arrangement, but that closeness changes every couple of years. The oppositions have a different configuration. So 1995, a little better picture. 65 million miles from the Earth. There was no photo in 1993. The Hubble was being upgraded, and they didn't take a Mars opposition photograph in 1993. But you're seeing the polar ice caps. You're seeing some clouds in the atmosphere of Mars. In 1997, even a better image. Mars 60 million miles from Earth. 1997. 1999, again, polar ice cap, some clouds over here towards the right, and some more clouds down here. 2001, and some clouds up at the top here, ice cap down at the bottom. And maybe a comment on the ice cap. Carbon dioxide and water ice. Carbon dioxide and water ice make up the ice cap. And the southern pole gets colder than the northern pole due to the tilt of Mars at this time. So we have red color from Mars with the rusty iron in the upper soil. And there's some dust storms that are obscuring some of the detailed feature of Mars that would be located here usually, and also at the north. There's some dust kind of interfering. Then 2003, this was the best of the recent oppositions, and best meaning closest, and giving a bigger angular size for Mars on the sky, Hubble could then get better details. I don't remember what the smallest size here, something like 12 miles, maybe 11 miles is my memory. But the smallest feature on here, let's say 12 miles across. But again, polar ice cap, and there's another view also, I think, another hemisphere here for Mars. And this one does show Olympus Mons, a huge volcano on Mars. And there's some other volcanoes here, these three kind of dots you see in a row. But let's just talk about Olympus Mons. Roughly, this is 360 miles across the base of Olympus Mons. 360 miles, huge. Cover up a good portion of the state of Nebraska with this single volcano. I think I've heard also cover up Arizona would be the area for this volcano. And again, polar ice cap. Let's continue on. That's 2003, 2005. And these pictures are not all the same scale. Some of them have been blown up a little bit compared to the others. But 2005, still nice details available. The other hemisphere in 2005. And then just a single slide showing the two hemispheres. Let's continue on. 2007. And views of the different hemispheres in 2007. And then kind of a mosaic or a collection. So you can see the different angular sizes of Mars. And 2003 was our best configuration. Though this image is set properly for the size of the planet as we would view it. 2003 is the largest angular size because Mars is close to us. Mars does not physically expand or shrink as a planet, but this apparent size here is because Mars was closer to the Earth, better situated for viewing. And then I could not find any opposition photos of Mars from in between 2007 and then found this one in 2016. Again, clouds you can see in different places. Mars has a very thin atmosphere, but it does have carbon dioxide clouds. And then some labeling of the photo that you just saw. And again, clouds being pointed out for you, and the polar caps, and different named features on Mars. So I just listed out the oppositions. The group here, I didn't put the 2016, but I wanted you to kind of see this pattern of when opposition occurs. So December 1990, and then January 1993. That's 2 years and a couple months. From 93 to 95, that's 2 years and a couple months. You know, early in January, later in February or something. March, then in May 1999. From May, this will be early May. This will be later in June. Again, 2 years and a couple months elapsing. 2 years and a couple months. 2 years and a couple months, and the pattern repeats. So there is this regularity of when opposition occurs, and this also leads to regularity in when missions to Mars are launched. That about every 2 years and 2 months there's kind of a launch window, and when the configuration of Mars, it makes it the easiest to reach Mars with not having to use too much rocket fuel. If you like looking at some more of these videos, physics videos, astronomy videos, these websites list them with the name, roughly how many minutes the video takes, what content. If you do enjoy these videos, it would help a lot if you would watch a video on YouTube and subscribe to my YouTube channel. Thank you.